later, just to get it, just make it there available to you guys. So we have learning objectives here. Our objectives to construct tables of data. This everything today is so straightforward. We know the difference between an equation and an expression, and I just have them listed here. That's why I don't think you have to write down very much of what these words mean. So we should be okay with that. Section 1.2 are these objectives. There are a few things I want to go through with you guys. So here we go. The symbol for natural numbers, which are the set of counting numbers, 1, 2, 3, 4, 5, so forth, is denoted by an N. Whereas the symbol for whole numbers is that like a double, like you guys have all seen for, I bet you guys have all seen for all real numbers, that, right? So that symbol, well, it's kind of, that's what that's standing for, like the double W. And we know whole numbers start with 0 and then so forth. We know the difference between a prime and a composite. A prime number is only divisible by 1 in itself, whereas a composite number is a whole number greater than 1 that is not prime. And look, notice down here for integers, the symbol is a Z. The symbol is a Z. So if I give you this chart here, oh, excuse me, I'm not the chart yet. The numbers, another symbol we have is this little E, if you will, with the curvature capital E. That's read as, so if we look at this right here, 3 is an element of natural numbers. That's what it means. So isn't 3 a part of the natural number set? And then this symbol right here is called subset. So subset's a smaller group from the bigger set. So if we look here, natural numbers are a subset of whole numbers, whereas whole numbers are not the subset of natural numbers. Okay? So if I said if I said I have whole numbers, 0, 1, 2, 3, 4, 5, and so forth, right? Isn't the numbers 3, 4, and 5 a subset of whole numbers? And isn't the number 3 an element of whole numbers? So that's what I mean by that. Okay, I like this chart for you guys to look at because we have real numbers and then we have imaginary numbers, which you know bring in I. But in real numbers, they're either rational or irrational. Irrational are simply numbers that cannot be written as a fraction. So it keeps on going. That's why we know pi, the square root of 101 is 10 point, keeps on going. Whereas rational numbers can be written as a fraction. And then the subsets are integers. A smaller subset is whole numbers. And the smallest subset is natural numbers. So I think that's a good diagram for us to see to make sure we're good with that. Objectives for 1.3, I have them listed here. And then I also, you don't have to write this down, I have listed 1.4s and 1.5s. And then I do have a few examples that I'd like to do with you today. And I'm going to start off with just a silly problem. I'm telling you this. And this is, I'm telling you A is equal to 1, B is equal to 1. So would you guys agree then, if A is 1, B is 1, A equals B? We're all in agreement with that, yes? And then we know in algebra, if I do it to one side, I can do it to the other. So I'm going to multiply both my sides by A. If I multiply both my sides by A, Ms. Hayden, what's this left-hand side become? A times A becomes?
1, right?
Well, in terms of variables.
A squared.
A squared, there we go. All right, there you go. A squared. Mr. Peters, if I multiply the right-hand side also by A, that becomes what? Well, on the right-hand side's a B. I'm multiplying B by A, that becomes what? AB. There we go. I agree with that, right? And now what I'm going to do is I'm going to subtract B squared, which is 1 still, from both sides. So I'm going to write that for you. So if I take A squared and I subtract, boy, I don't know why I wrote that so small. If I take A squared and I subtract B squared, it becomes A squared minus B squared. Would we agree with that? So what's on the right-hand side? What's AB minus B squared? It becomes AB minus B squared. I'm keeping both equations balanced. Agree? All right, so now I'm going to factor both sides. What's the difference of two perfect squares? That A squared minus B squared. What's that factor into? Anybody have it? Top of their heads? I know it's been a long summer. What's that factor into? Bueller? It's going to factor. I'll help you out here. It's going to factor into what? A plus B times A minus B equals, and on the right-hand side, I'm also going to factor. I'm going to take out a GCF. I'm going to factor out a what, guys? A B. So if I factor out that B, I'm left with A minus B. Okay, watch this. I'm going to divide both sides by A minus B. Oh. I'm going to cancel. And I'm going to be now simplified down to A plus B equals B. Everybody good still? I'm now going to substitute in. At the beginning, I told you guys A is 1, B is 1. Well, 1 plus 1 is 2. I just proved for you guys 2 equals 1. Again, because right here, when we divided by A minus B, I was dividing by 0. That's invalid. Okay? I thought that would be a good place to put that in. All right, so let's see here. How many freshmen do I have in here? Raise your hand again. Okay. How many sophomores then, just to give me a visual? I got a few sophomores. Okay. All right, sophomores, right? Because you guys are, you've been in high school for a while. You guys get up, sophomores. I got all this board space. All sophomores go find a place and get a marker and solve this problem, while all freshmen at their seats work this problem out. Let's see if we can do it right. My recommendation is my first step would be, you got to stand up too. So get up. Hey, stop. Everybody, you know what? I'm going to hit pause for a second. All my activities.
Is it Tommy Boy?
No. Good, great movie, though. Step Brothers. Remember they make their bunk beds? Yes. Look at all the room we have now for activities. Do you guys want help with the first step? Half of 2x is 1x.
Yeah.
Oh, wait. We're going to get half of 3/4 would be 3/8. Then I'm going to distribute a negative 1/3 through, which becomes negative 1/30. And then negative 1/3 x equals 1. Does everybody have that as your first step? Okay, now put parentheses around the entire problem. Let's clear fractions by multiplying by the least common multiple of 30 and 8. Is it 120? I think it's 120. Doesn't 120 go into 8? 2, 4, I think 120. Try it. Try multiplying everything by 120. Well, what do you need a calculator for? What? I'll do it. What's 120 times x? 120x. I survived there. Plus, okay, here we go. What's 120 divided by 8? Okay, I got to think in my head. Be 140, 15. Wait. But then I got to go 15 times 3, 45. Do you still need one?
No,
I got you through the hard part, didn't I?
I got it now.
Okay, good luck. Somebody's going to blow it. One of these sophomores is going to blow it.
You have to have a fraction. That's so
So let's see. 120x minus 40x is 80x. Plus 5 equals
Oh, that's different. I got it.
120. I messed up. Where did I mess up at? Oh, it helped.
Yeah,
40.
it's 1
Where am I? Where I messed up somewhere. Where at? After the 45? Oh, that should be minus 4, shouldn't it? Look at that. See, I messed up on purpose just to give you guys, make you guys feel better about yourselves because you're all stinking too. So let's try that again. How about 80x? Let's see, plus 41, subtract it over, that would be what, 79? X equals 79 80ths? Nice. Take a seat. Take a seat. What are you waiting on, Maya? Okay. Where's your eraser at? Why are you missing? Oh, there's one of those erasers are over there. Go over there, Maya, and grab it. Erase your board before you go sit down. Thank you. Thank you. How was that? Was it hard? It was hey, you know what? We'll call it to summer. Summer happened. Life happened. Don't worry, sophomores. Freshmen, get your butts to the board. Go. Oh, now you guys are breaking stuff. It'll go back on. You're getting like 0 equal. Oh, I messed up. 0 equals 5/3 or 0. Maybe you distribute it through first. I don't know. But you get 0 equals. So what am I going to say? I'm going to say, you could say no solution. You could show me an empty set. This also means empty set. This is how you write an interval notation. I had a student, no joke, one year. Here, let me hit